Hi, good morning. It's 10 o'clock here in Vienna. Um, this is the routing area open meeting. John, are you online? Okay, so we're going to wait a couple of minutes for John to get on. He's going to share the slides. Okay, so again, good morning. It's 10:01 here in Vienna. Good afternoon, good evening to everyone else. Thank you for being here. This is the routing area open meeting. It was pointed out that this is not the first time we have a hybrid meeting. We've always had hybrid meetings. The difference this time is that we have a lot less people on site, of course. I am Alvaro, and we have John and Andrew on the screen. Martin is also here. You gonna say hello, Martin?
Yeah, you hear me?
Yes, we want to see you too.
Yeah, but I'm having troubles turning on my camera. Give me a sec.
Okay, we can. Um, okay, so let's. There we go. Hey.
Sorry.
No. This is great. So this is the time of the year where we have 4 of these here in the front of the room, because today is the day where we have the changing of the dots. If you want to see the exciting ceremony later on, the plenary is tonight, where the formal change of leadership will happen. So let's start with the slides, John. If you were saying something, you were muted. But so we've all have seen the Notewell slide. We're familiar with it. Please keep in mind that this is not just about intellectual property and contributions. It's about behavior as well. There are links to a number of BCPs down there. And we chose to highlight a couple of the things from RC 7154 about behavior. Treat people with respect, speak slowly at the mic. Keep in mind that there are people from all around the world that speak different languages. This is about engineering. Let's keep the discussions technical to try and find what the best solution for the internet is. This should be something that we all keep in mind, not just when speaking at the mic, but we're interacting with others at the meetings through the IM, and also, of course, on email after the meetings. Next, yeah, we have a couple of meeting tips. Hopefully, you're all familiar with the different buttons by now in the MeetEcho interface and in the agenda. That little phone icon there is the one where you can locally here in Vienna get onto MeetEcho, get onto the queue, etc., things like that. For the remote participants, make sure that you share audio and video when you are speaking and turn it off otherwise. Video is fine if you're presenting. Otherwise, we would like to keep that at a minimum. And hopefully you all tested your sound and everything before the meeting. The next slide, we have some general links to other resources here in Vienna or here in the IETF 113. Next. We're always looking for feedback about us SADs. How are we doing? What can we do better? There's always something that can be improved. We're doing good. It's always nice to hear that as well. not only about our performance, but about the area in general as well. What needs fixing because it's broken, what is actually working, what can be enhanced. Maybe it's not broken, but we can do something better. Please, you can come to us individually. You can go to any of us at any point. Something really important in the role of us as ADs is document review, and should be very important for all of you as participants and working group chairs. The quality of anything that comes out of the IETF depends on all of us. Please review documents. Please participate in the discussions as the documents progress through the working groups, through the last calls, through the IETF last call. Engage in all parts of the process. Please, please, please. So here's the agenda for today. We're going to spend some minutes on just administrative stuff. Then we're going to have some working group updates in this order. If you're here in the room, please come up here to the microphone. If not, of course, connect to the Miraco audio. In the second hour, we're going to have a presentation from Adrian Perig about Scion. He'll talk about where the work is and deployment experience that they have. And then we should have some time at the end for any open discussion that anyone has. So as I said before, and I'm going to actually stand over there for this. I said before that this is the time of the year when we change leadership. Martin ends today his 4-year tenure as an AD. During these 4 years, I have been truly honored to work with him. He has, I can very confidently say, had the full experience of being an AD and IASG member. He has had all types of working groups that are quiet and nice, working groups that are not so quiet and so nice. He's even been able to help us, the other ADs, in resolving conflict, stepping in to resolve conflict in other working groups. Thank you for that. He has had groups that have very straightforward technology, groups that are mature, like for example in PLS. He has had groups that have more complex technology, where we end up with 27 different forms of doing things. If you're ever participated in BESS, you know who you are. He has shepherded the working group for all 4 years. He has also been participating or shepherding the working group in Babel, which is a new protocol. So far, I think there have been 6 or 7 RFCs published from the Babel working group. Again, a new protocol, new work that we brought into the IETF a few years ago, including the protocol spec and different other mechanisms in there. He has been shepherding several BOFs that have had impact on different areas where he has had to interact with not just ADs, but people in everywhere, from the application area, security, transport, everywhere. He has shepherded BOFs around work that has to do with other SDOs, where the IETF has had to engage and liaison exchange and discussions about whether the IETF should do work or not in relationship to other work going on elsewhere in the industry. He has pretty much done it all in these 4 years. And he still has found time to review documents, to participate in IESG discussions, and to spend time with his family. He's not here at the IETF. He's spending some time in Normandy with his wife and his son, or skiing in the Alps. Martin, in my opinion, has been one of the great ADs that this area has seen. And I'm very happy that I can call him a friend. So thank you, Martin, for all the work, the time, and the dedication that you have put into these last 4 years for the IETF. And we know that you will keep putting in more time and more dedication and more effort in the future. Please, I know that Martin's not here physically or in any of your homes either. Please join me in thanking him. Thank you so much.
It's all true.
Thank you very much, Alvaro, for this very touching long series of words. You were talking about family. I'm actually taking my son to school. I'm sorry. Life has been messy. We're just out of second COVID in 4 months, so trying to cope. Thank you. Thank you very much. And thank you all for being kind enough with me over these years. Thank you. No, I'm very touched, and I'll think of a longer message. And I wish all of you three all the best. So John, Alvaro, and Andrew for this new cycle. Thank you again. And yes, you can call me a friend, and I call you a friend, Alvaro.
Thank you, Martin. So we have our new RD, Andrew. He's on the screen. Andrew, do you want to say a few words, introduce yourself?
Yeah, hi. I didn't really bargain on saying anything, but I just wanted to say that I think it's an honor and a privilege, and I will do the best I can, and I'm always open to anybody approaching me if you want to chat or anything. I was kind of lying last night thinking, and it's interesting for me because particularly coming from where I come from, and being in Africa and taking a seat as a routing AD from Africa as the first IETF or IESG resident from Africa, I'm well aware that the continent is kind of looking to me, and I'm aware that going into this role, I've got it's an interesting situation for me, and I want to do the best job that I can for everybody. And I'm looking forward to working with all of you. But please feel free to contact me, reach out. I know I'll be reaching out to all the working group chairs under me after today. And yeah, let's carry on.
Great, thank you, Andrew. So Torles is on the mic. He didn't get on the queue, but okay. Go ahead.
Tolles Eckert. Yeah, I was on NOMCOM this year, and I just wanted to say thank you very much that we had 3 excellent candidates on the roster, a lot more than other areas, right? So very happy about that, and also about all the feedback we got from the individuals to help us make the hard decisions. So, and I think it would be great if we get even more people from the routing community next year around. I'll have to say that maybe to the 3 of you, I'm not sure, I haven't seen something comparable to what Warren did in the ops area, trying to, question the community to, prepare for next year's NOMCOM and get even more candidates. So that, and also the feedback from the community. So, but yeah, thank you very much again to the 3 of you, and welcome, Andrew, to your new job.
Thanks, Torles. So in case you don't know, what Warren in the ops area did is he sent an email to the whole ops area or somewhere asking for interest in people to not only become AD, but to become chair. So, he was trying to, build up a group of names, right, to consider. Sometimes we know you because you participate. Sometimes we don't know if you're interested or not. And the same applies here. If you want to, if you're interested in participating in any of the positions, please let us know. If you want to know more about what it takes day to day to be the work of the AD, please approach any of us. we'll be very happy to tell you all the exciting perks, the extra pay, the extra food that we get, et cetera. And all the sort of extra work that we have as well. It is important that we maintain, the continuity of the IETF. There's been, there's a lot of work, good work, important work that we do. So yes, please think about it. And, there's opportunities all the time. Great. So besides the huge change, of course, of ADs, the area hasn't changed a lot more. We haven't opened or closed any working groups or rechartered anything in the last year or since the last meeting. And we don't have any new chairs. We have 2 BOFs that have been approved. One is called MSR6 for multicast segment routing with IPv6. This is a BOF that we approved, but we haven't held it yet. We have been working with the proponents to get them ready. We're probably going to have a interim BOF sometime before IETF 114. So please look out for that. We will try to find a time, or probably a couple times, so that we can have the maximum participation possible. John, you want to say something about CAN?
We had the CAN BOF, gosh, was it only yesterday? So the CAN BOF wasn't targeted towards creating a working group. I think a lot of you were there. There was a great deal of energy, I thought, at the BOF, a lot of good back and forth with the proponents. I'm not really going to try to summarize technical outcomes because that's what the slide sets and so on are for. But I think probably the big takeaway is there was a lot of energy around it. There was good feedback to the proponents that probably the single most repeated comment was, please don't fix your problem by shoving state into the network. Of course, that might just be me engaging in a little confirmation bias too. Or I should say pushing state into the underlay, which is a different thing. Subsequent conversation is going to take place on the Dimecast mailing list. Anything to add from any of the other ADs or people who are there? Anyway, I do encourage people to get on the mailing list and engage in the conversation, because I think that this will be a continuing topic.
Great, thank you. So the last slide we have before we go into the rest of the agenda is the working group distribution. So this is how, starting today, tonight after the plenary, or I guess during the plenary, the working groups will be distributed. So that's it. If you have any issues, go talk to your AD. If you need to talk to anyone else, feel free to talk to any of us at any point. So we're going to go into the rest of the agenda. The first thing that we have is a report from the Routing Area Directorate. Hao-Mian.
And just before we launch into that, let me say I've been flipping slides so far. I will continue to do so. If you want me to pass control of the slide clicker to you, while you're speaking, just let me know and I'll hand you the controls. But other than that, just do the usual next slide thing.
Sure, thank you, John and Amaro. This is not a long presentation, so please help to flip the pages. And yeah, this is the update of the reporting for Routing Directorate, and this team is composed by the top experts from routing areas. Yeah, second page, please. Yeah, everybody is now appointed by the ADs, and actually right before this meeting, probably in the January and February, we the ADs work on some personnel changes, and we have replaced about 5 people to be substituted in the team. So this should be a kind of farewell to John, Isbrand, Dave, Andy, John, and Manav. They left the team because of different reasons, and it's time to say thank you for all the contribution in the past. And meanwhile, we are welcoming new members: Zhao Hui, Jian, Shuping, Donut, and Mohammed. So we wish to collaborate with you in the future. And as usual, the purpose for this team is to review the drafts, the last code draft and early review to the routing area work. And we are also providing the review for some related work in other area, for example, OPS. And if you are interested in understand us, please check the wiki page. And next, please. So here are some statistics from a summary of statistics since the last IETF, and we have periodically update these figures from 2020, and we have now more than 100 early review and last call review so far. And from last IETF in November, we have succeeded in 3 early reviews and 13 last call reviews. So this is basically in normal average from only the numbers of review requests. And we also, in the right-hand figure, we have the distribution on the review requests for different working groups, and the top 3 would be IDR, BES, and LSR. And next page, please. So finally, yeah, this is the distribution or the percentage of the result, because each of the review result would be shared with working group chairs and feedback to the corresponding working groups. And basically for RTG area, for routing area drops, so we are having around 100 of that, and basically we have 1/3 of them ready, have nits or have some issues. Only a few of them label as not ready and request further work. And right hand, we list all the non-routing error drafts.
So I think we lost the last part of your presentation, Hamian. Thank you so much. Yeah, the Routing Directorate has a very big impact on how on the quality of our documents. So thank you so much to everyone who has participating and continue participating in the Routing Directorate. So we should move on. Before we move on, please remember to scan the QR code next to the tables for you guys here on site. That takes care of the blue sheets for us as well. So we're going to go into the working group statuses. This is a few minutes, 5-6 minutes or so per working group. Talk about some of the highlights in your working group. So beer, Tony, I'm assuming you're here.
Yeah, you guys hear me? Quick check. Yeah, okay, excellent. Right, so I'll make it relatively snappy. Beer, by now everybody should kind of know what's going on there. Next one, please. Usual no dwell. Next one, please. Okay, so we active a bunch of RFCs published, about 17 active drafts on the work, last call 2, ISG 4, and we have about 14 drafts like in different stages of discussion, you know, adoption and ideas forthcoming and so on. So this is the amount of activity. Next one, please. Okay, so what was notable? What was happening? We have FRR work for beer going on, you know, 2-3 different solutions. We have multiple drafts, good discussions, stuff kind of converged. Last issues being resolved to get the stuff adopted. The TE work, the beer TE work is kind of finished. The stuff is being published. A lot of spec coming out there. From Jeffrey's side and some other authors, multicast as a service is going on. We had pretty rough going, but at the end convergence on how to carry beer in IPv6, so that's done. There's a bunch of interesting proposals on OAM and work going on OAM, so those are kind of the notable things. Stuff I didn't put up here, so we're seeing more and more adoption, we're seeing some new silicon, and we're seeing a full P4 implementation. Hollow Giant and some of commercial folks are getting onto a beer backbone, and traditional multicast is being hooked up to that, so there's a lot of activity there. Next one, I think that's it. Yeah, thanks. We're brewing beer. If there are no questions, I'm kind of done.
No, thanks, Tony. Go ahead, Mike.
Thanks a lot.
Yeah, so let me just give a brief PIM summary. The work that is probably the most interesting to, is there a question already? From Darren? Nope. Is work that's related to segment routing and point-to-multipoint work. PIM, as a reminder, is protocols for IP multicast and not specific to protocol independent multicast. And so a couple years ago, almost, in working with the Spring chairs and the working group, we've taken over the responsibility of segment routing and point-to-multipoint work. And we've just had an informal agreement with Spring to address such proposals. And we are in the process of making it official in our charter. We are waiting on a few things before implementing it. But basically what we'll add is something like what we have here, is that is to develop point-to-multipoint protocols, including SR, SRv6, P2MP work in agreement with Spring. This may also require point-to-multipoint protocols as requested from other working groups, which I'll get to that last point in a minute. So since then, we have adopted a couple drafts in this area. The segment routing point-to-multipoint work, it creates a policy to instantiate a point-to-multipoint tree by stitching replication segments together. And the replication segment itself is defined in Spring. So we're doing the P2MP policy in PIM. There is a lot of related work that's happening in other working groups, and I'll have to say it seems to be working pretty well. I really appreciate, for instance, IDR just recently, Sue, reaching out to us and other working groups just to let us know that this is going on in their working group and how we wanted to handle it. And so that first draft you see there is being is modifying BGP-LS, and so it's being handled in IDR. Another related draft is being worked on in PCE, since it's specifying extensions to PSAP, and something similar in VES as well. So this whole area in the past has been somewhat confusing of who handles what. It seems like we've kind of come to an agreement of what we will and will not do. I think for PIM, we're taking on the SR related work in agreement with Spring. And as far as these other working groups are concerned, we'll just get involved as they request us to get involved. And they seem to be wanting to handle their own point-to-multipoint work in their own working groups. Next slide and last slide. So there's other work as well that's somewhat interesting. Of course, there's the Yang drafts that we've been working on. But there are also some DR improvement related drafts in PIM to make the DR election less likely for packet loss, and to make that DR election more sticky, so that like when a new DR that has a higher priority comes into the network, it doesn't immediately become the DR, but the other one, it remains as the DR. And so, and a new backup designated router role, which is also being proposed, that we've adopted, which will immediately take over without much packet loss. So we have these two drafts that do similar things, just kind of a different approach, and we're trying to decide whether we progress them further, converge them, and we'll be talking about this on Thursday when we meet. And then just some other, as maybe some interesting work that you may find interesting, is there are some new drafts that are being proposed, such as PIM Lite, which there may be some instances where there's some interfaces that don't want to have the overhead of PIM neighbor relationship, but still want to accept joins, prunes, and asserts. And so there's that draft that's being proposed and it'll be presented this week. And there's also MRH multicast routing header related type of presentations that are that are proposed, if we have time, to be presented as well in PIM. So come join us on Thursday if you can. Thanks.
Thanks, Mike.
Okay, working. Hey, hello. So this is Gunther speaking here. I'm going to make a quick update on the LSVR working group. So we have our session tomorrow at 10 o'clock. So the agenda, what I've prepared here in a couple of slides, is like, first to explain where we are with the LSVR and the time schedule, quick understanding of what it actually is, and then we're going to cover the next steps of the working group itself. So next slide, please. So we started our work, so we got created around IETF 101, so that's about like 4 years ago, I guess, which is quite a long time. And then we were given a shot, to be in existence and to work upon our deliverables for about like 2 years, 3 years now. We failed a little bit there, and we're still working on this thing now. Now the good thing is that at least right now we have a protocol spec which is considered to be ready for IESG. It went through a few cycles to the routing directorate that previews on the working group. It went to to IESG already. They sent it back. It got approved, and now we also have confidence. So next slide, please. So here, so the 3 deliverables what we had to complete at the end of this working group would be an applicability statement, the LSVR spec, and the description of how each link state vector actually looks like, how the transport actually works. So as I mentioned, we consider this ready now, and the work we have is ready to be sent towards IESG at this point in time. Another part of the deliverable, of course, is also we need to manage this technology. We need to have like a Yang specification for that. That is pending upon further IDR work on BGP, because the LSVR, based upon BGP short-to-spot forwarding, is leaning a lot upon the BGP technology, on BGP-LS more specifically. So next slide, please. So if you look into the different components, so we can actually carve them up into 4 different sections here. So if you first look at the bottom one, it's like each router. It will actually have like link states, so that needs to be harvested. And initially we were looking into LTP version 1 for that. But what we discovered is that there may be there's not enough space in an LTP packet itself to describe and to exchange all the protocol information required. So we developed first a requirement of what would be necessary for that, and then we developed L3DL, and we also worked with them together with the IEEE into enhancing LTP. We crafted, as a result of that, LTP v2 actually was created from that. Now, once we have the linked information of a router, it needs to be encoded into some sort of a common understanding of, and that actually needs to be shared, between all different routers within a particular area. And that is done by, the router link state distribution, and that is where BGP SPF comes into place and the BGP technology. And on top of that, we also are using like SPF for the routing table calculation, and that is where BGP SPF deviates, from what traditional BGP is doing. So here you can see also on the top left-hand side, so LSVR is using, for calculating the routes like BGP SPF, and that is what describes actually our work in our main specification. So next slide, please. So initially, when we were looking into different kind of solutions, we selected, a BGP-based solution. Why? Is because BGP is really, is a very well-known protocol. It is stable. It scales, it scales a lot. It's very, many people actually know it has reliable transport. It has guaranteed in-order deliveries, all, fancy and good things. The downside of what BGP is that it's, it uses like path hunting, and it's a distance vector protocol itself, which is maybe not the most optimal at that point in time for describing a topological database within the network itself. So for that, we used like, we decided to go for BGP LS on that one, and change the way it calculates the routes and how it distributes links and information between different nodes in the network. So next slide, please. Yeah, so just to say, short, so LSVR is not technology which, intends to be used for like small networks. This is really for, massive scale data centers, and is, very well tuned for that. So quickly go to the next one. So here we have like, an interesting slide here. So this is something that got, so the PDF looks a bit different from the PowerPoint itself. So some graphs actually were changing. So what you normally would be seeing here is like each of these routers has like a small puzzle piece, associated with it. And the puzzle piece actually describes like, who am I, who are my neighbors, and what is the customer neighbors, together with some other link properties associated with it. Just a typical graph of what you would see with the classical link state routing protocol itself. But in this case, these pieces of the puzzle are exchanged by using, a BGP LS, and then more specifically by the BGP SPF variant of that one. And we also have like a new SAFI for that, which is like SAFI 18. So the next slide, please. So from the peering models, so what we are using for this is something reasonably simple, well known again, and we will be using, actually we are using like route reflector technologies for this. Some people may also want to call it like a controller, because there may be more things you want to do with it, from a small, and be a bit more smart on how you actually use topology harvested through the BGP SPF. But in essence, you use like a hierarchy of route reflectors, and they don't necessarily, they're probably going to be like directly connected to each other, but they don't have to be. So if you preload, topological information, they don't really have to be directly connected. So next slide. So what we have changed with BGP SPF, so this is the base spec of LSVR, the link state vector routing, is so in the classical path vector algorithm, you have like the two phases, like phase 1 and phase 2 playing on the router. So first you get like your routers in, your routers in, and then you have a calculation of degree of preference of each of these particular entries. Then you select the best one out of them, and then you actually forward those best routes, to the rest of your neighbors. So what is done in LSVR is slightly different, and there we follow what SPF actually is doing. So each router, in this case, each piece of the puzzle here will have like a unique NLRI. The router will get it. It will, put it into its database itself, and it can actually directly forward it towards, all other routers and all other neighbors, as such. And then it can actually do the route calculation, the best path selection, and after that. So that's quite a big win from a convergence perspective in big networks. So next slide, please. We're almost there. So there are some benefits here for using BGP SPF compared to classical BGPs, because we use the the SPF technology here, which means you don't really have to wait upon selecting the best path. We can forward the NLRIs directly and then do the calculation afterwards. And we also have, because we have, the BGPLS encoding itself, we will get like at the end, like a full topological, information of the complete network itself. And also, if something actually happens in the network, we only will communicate the change in the network without actually having to resend like all of the routers which were impacted by that particular change. So next slide. So this is the last one here. So where are we right now? So we have like, our base spec, BGP SPF 16 was last updated with the IANA code points which were requested. We actually have like, almost finished draft also of the L3DL work. Now this part of work has not been fully in line with what we were chartered to do. So that is something we will have to change before we can progress it also onwards towards the IESG. So our next step actually is, first, we consider that the key deliverables actually are completed right now. So the base spec will be sent up towards the IESG, once the shepherd actually finds the time for that. And then next, we have to go through a recharter to include to work L3DL as a formal part of the working group itself, so that we can actually, formally, progress this and as a formal work item itself, even though it actually has been progressed, where we are. And then, of course, also we still need to manage this whole technology itself. So we need to have a Yang specification upon that. It is in the works, but it is waiting upon an IDR for the BGPLS setup. Yep. So that is it actually. If no questions, then we can move to the next one.
Thanks, Hunter. Jeff, you want to come up here?
Okay. Quick update for Rift. The base spec is still in reviews, and I would like to specifically thank you, Alvaro, for all the work. Been really a huge amount of work done between authors and Alvaro. It's really progressing well, so we expect further progress by next IETF. Applicability statement, we are waiting for Alvaro to review. Yang model caught up with the latest changes to the base spec, so working group last call in progress. We expect to finish it after this IETF. Key value registry as well in working group last call, and will be finished after the IETF. Auto VPN is good progress. There's already implementation of it. Segment routing, it's in progress, normal working process, and we plan to adopt it as a working group document after this IETF. And multicast, there's no really progress. We don't see a lot of traction in the industry, so for time being, it's just, backend. Questions? We are still working on the second implementation with open source community. There have been some issues about GPL towards Apache licensing. We are trying to resolve this.
Thank you.
Hello, hi everyone. This is Daniele reporting on updates regarding the CCAMP working group. Actually, I would say that 90% of the work that we are doing in CCAMP in these days is related to Yang models. Here, we decided to provide an update split by technology. So as you can see here, the three main technologies we are working on in these days are optical networks, where we do wavelength based switching, OTN networks, which is the so-called electrical layer of the optical networks, where we have time division multiplexing, and microwave networks. So the approach that we used and we are still using in defining Yang models for these different types of networks is to start with what we call the types. As you can see here, we have the layer 0 types for optical network and layer 1 types for OTN networks. Basically, this is a common data type which needs to be imported for WZone, for FlexiGrid in layer 0, and for OTN in layer 1. We are actually working on a BIS for layer 0 type to include the transponders and impairment awareness. So as you can see, are also in the next bullets, we did pretty a lot of work in the impairment-free type of networking. Basically, we assume that reachability is the only issue when connecting devices. In this type of approach, we define the topology models. This is what we call WZone or FlexiGrid. WZone is optical networks with a fixed grid. Each channel has a fixed grid. For this type of networks, we have defined topology and tunnel models. We did the same for flexible grid type of networks, where basically the grid is not fixed, and it's possible to define channels with the configurable frequency and the channel width. Now we are moving towards the next step, the one bolded, which is optical impairments topology. This is something that will allow for better interoperability between different vendors, taking into consideration optical impairments awareness in networking. It's something that is making things absolutely more complex, but will finally break the fact that most of the networks come from a single vendor. Similar work is done in OTN, where likely we don't have to deal with optical impairments because everything is electrical. We have the layer 1 types, topology, tunnel model, and something which we are starting to work right now. This is a draft that we recently adopted, which is OTN slicing. We are discussing about the possibility to do network slicing at the lower layers, so at lower than the packet switching. There is quite some discussion over there because someone believes that we just need to build an applicability statement on how to use OTN networks for network slicing. Some others believe that OTN deserve its own slicing methods. Here, obviously, a lot of alignment with these is needed because they are the owners of network slicing, and I mean, most of the discussions are done in conjunction with them. So we believe that good alignment is there. For microwave, we've been working on the modeling of radio links, and we are now working as working group on the topology. Next, please. Again, young models. So we are not just working on topologies and tunnels, but also services. We defined the layer 1 service model. Probably now we are not considered it yet, but maybe some alignment with the OPSA working group might be needed here, since they own the layer 2NM, layer 3NM models. This is something we need to consider. Client signals and topologies. Again, the transport network is used to carry upper layer type of services. Here is where we are discussing how the client signals are carried and mapped over lower layer topologies. And then network inventory. Here probably we need some alignment with other working groups. Basically, we have this is a new individual draft that has been recently proposed in CCAMP. They are working on the data model for network artery inventory. This is pretty much optical related, but I would say that some let me say, non-technology specific work is needed here. So here we are seeking for your advice on which working group we need to align with. Next, please. Other topics, these are the few non-young related topics. The applicability of GMPLS to OTN networks beyond 100 gigabits. How to use all the young models defined by the IETF on the northbound interface of a network controller, of an SDN controller. LMP. LMP is the protocol owned by CCamp for link management. We have some extensions for LMP there. And some new work on the usage of optical networks to interconnect data centers and cloud. In the next slides, we have a very short example of the two, let me say, topics where alignment with other working groups is being done or is needed. As I mentioned before, OTN slicing is the first one, where we already have alignment with the T's ongoing. As you can see on the right, that's the architecture defined by the T's working group. The OTN slice controller is being added with several options, where the OTN slice controller is directly connected, directly controlled by the end-to-end orchestrator, the end-to-end slice controller in option 3, by the IETF network slice controller in option 2, or let me say bypassed in option 1. Next, please. Here, I stole a slide from the presentation that the team working on network inventory is going to provide next Friday during the CCAM section. And this is basically to highlight the question that we are asking ourselves. Is there some generic work that needs to be done somewhere else, and then in CCamp we need to augment it to be technology specific, to be optical specific? This is again an open question. Next slide, the last one. Milestone to be updated. We are working on that. Milestones were pretty outdated. We will present our proposal to the working group on Friday, and John expected to receive it for approval immediately after. That's it from our side.
Thank you, Daniele. We're going to go over to Tees.
Hi, is my audio coming through?
Yep.
Okay. My name is Pawan Biram. I co-chair the Traffic Engineering Architecture and Signaling Working Group along with Lou Berger. Luis Contreras is our working group secretary. We also have a distinguished tech advisor, Adrian Farrell, who keeps us honest from time to time. For those of you who don't know what Tees working group does, I would let you go through slides 2, 3, and 4 at your own pace and reach out to the Tees chairs if there are any questions. For now, let's just jump to slide 5 that covers the ongoing activities in the working group. Okay, so we currently have about 22 working group documents. Given that we spend a lot of time discussing architectures, it shouldn't be a surprise that there's a lot of T-specific data modeling work that gets done in the working group. There are weekly open design meetings that are happening for some of these. These are primarily driven by the authors of the various modeling drafts and are open to all. So do check those meetings out if there's anything here of interest to you. Most of these modeling efforts are nearing completion, so it would be great to get some thorough reviews in. RFC 3272, it's an IETF classic. Discusses the principles of internet traffic engineering. The only problem is that it was published 2 decades back and is tad outdated, rather more than tad outdated. We revisited the document and it was rewritten to make it more relevant to the current times. The editor has just told us that it's ready for working group last call. Hopefully this will last for the next 2 decades. So again, seeking thorough reviews for that document. ACTN, which stands for Abstraction and Control of T networks. It's an umbrella term for a set of management and control functions used to operate one or more T networks. These functions are typically used to construct virtual networks that are then presented to the customers. The framework for this was published a few years back. I think it was in 2018. We are now looking at how ACTN can apply to areas like packet optical integration and network slicing. Enhanced VPN, it's another framework that is in the works that caters to enhanced connectivity services. There is a fair bit of discussion in the working group about its applicability to network slicing and how it can be used to create the infrastructure to pin a network slicing service. That's enhanced VPN. Then we have this topic of network slicing itself, which has been hogging a majority of the airtime in T's working group sessions for the past couple of years. We have a working group adopted framework document for what we refer to as IETF network slices. We also have a working group adopted Young model draft that discusses how an IETF slice service can be requested. We also have various solution-specific documents that are being thoroughly debated and discussed. So we do understand that there are a fair number of network slicing-related documents that are being presented and being pursued in other working groups in the routing area. We would leave it to the other working groups to decide how they would want to proceed with those. But if there are any questions or concerns related to terminology or any concerns with respect to the framework or solution architectures, please do reach out to the TEAS chairs or send an email to the TEAS list, and we'll have those looked into. The working group is also working on a few GM plus specific items, like I think that there's a protocol extensions document for shared mesh production that is with IESG, and then we have a working group adopted document that talks about interworking of distributed GM plus control and centralized controller systems. So that's what we're currently working on. Our working group sessions are slated for today. We have 2 back-to-back sessions. Do come join us if any of these topics interest you. Any questions? Okay.
Thank you, Pavel.
And update for the routing working group. Next slide, please. To remind you, we were chartered to work on some work that doesn't have other home in IETF, such as young models for routing protocols that don't have working groups already or not yet, as well as say, most importantly, bringing new work that could potentially be dispatched into other areas and other working groups. So there are 2 different streams. One of them is to work on traditional documents such as FastRoute. Another one is to bring new work into IETF that industry is looking forward to be standardized, and we are going to discuss now. So our traditional areas are FastRoute, young models for things like VRRP, RIP, and other stuff that doesn't have home. Next slide, please. Ongoing work, BGP peak. There are at least 4 implementations I'm aware of done around 2015. So it has huge educational value for people who are coming networking right now and trying to learn how do we do faster route with BGP. You know, in some networks there are 50, 100, 150 million prefixes today. How do you converge fast below second, right? So this is an explanation of particular implementation, but again, educationally, a lot of people reading it, and for them it's really the document to understand BGP faster route. It's progressing. I think we are text-wise getting close to working group last call to finalize this work. It's been around for a really long time. TILFA being reviewed, and thank you Stuart Bryan for his very valuable reviews. So he is shepherding he's shepherding this work, and there are a number of comments he wants author to address, but the progress is there. ATN BGP work that describe BGP framework for mobile space and aeronautical work. It's a reasonably complex and long document. We're really happy to see that there's interest to review it, to help authors to improve it. So work is ongoing, and we expect to start working group last call sometime after this IETF. Next slide, please. We recently adopted BFD for VRRP, so we could use BFD to provide sub-second conversions for VRRP. You know, VRRP usually runs slower than 1 second, so the combination is very valuable, especially as EVPN is becoming de facto standard, and in cases where it's pure layer 2 VRRP is the technology to provide first layer 2 hub. Service 6 egress protection is in our traditional chapter. We are working on faster route for different parts of network, in this case, service 6. Net to cloud work is stalled. I don't think we are going to progress it. I mean, we've been trying to work with authors for a couple of years on it, and we don't really converge. Next slide, please. In YANK area, we've published RC 9067, which is YANK model for routing policies, which is used by all other routing protocols. Extended trip YANK model is ready for working with last call. There's no changes really. And the QoS model, it's really good work here. The addressing reviews, the operational consideration related draft is progressing. So after all the young doctor reviews have been addressed, we are about to start working with last call. Next slide, please. So new work, V3spin or VRP version 3 proceed to address non-inclusive language, as well as to integrate all the errata. Thank you, C, for taking this. Loop avoidance is, again, part of our traditional chapter, as well as midpoint protection. HPCC is new work, and I'm going to discuss a couple of items now that I see coming and are important. It's not very visible yet, but amount of traffic that have very different characteristics than what we see on the internet is coming. Amount of RDMA traffic in data center is going over the roof. Machine learning clusters are getting to 50 to 100 megawatt size. They require different type of feedback from end system into routing system. So HPCC is an approach to provide clean API between host and network and eventually influence routing. Another type of new work that's coming is semantic routing. Really what we are trying to do here is going further than just destination-based lookup routing system. What other fields can we use to provide better routing? What's new? What needs to be added to the packet in terms of encapsulations, in terms of additional headers, to provide this additional metadata to make routing better, more efficient, more load-aware, more application-friendly. So it's kind of more research area right now. There's some work going in IRTF. There's a number of drafts in routing, but we are in very early stages, still unclear where this work is going to happen. Actually, back to HPCC, we are in discussion with transport area, because on one side, it kind of influences routing, on another side, it's congestion control, really. What we want to do is end host to get enough data to either send less traffic or perhaps change entropy, so routing system have more metadata to load share traffic better. So again, it's all being discussed right now with transport area ADs and transport working group chairs. Last area is routing in satellites. We see really large deployments of satellites networking. We speak so Starlink, all the stuff is being deployed at huge scale. They all run proprietary protocols today. They don't interwork with each other. There's definitely need for a routing protocol that can address the requirements of satellite system, which is quite different than wired system due to changes, due to sometimes proximity and not in transition links that going up and down. So this is kind of early work we started here, but eventually I believe there's really need for interoperability between different systems to provide what ATF does best, really solutions that allows different systems to work with each other. So those are kind of 3 areas I see more and more discussions, and we'll continue working on them. Questions?
Tony, yes, we have a
How do
question
we
from Tony.
test satellite proposals?
Excuse me?
How do we ever test satellite routing proposals?
Very good question. I mean, we couldn't test SPF before we put together specs, right? So we need to start somewhere. We need to understand the characteristics of satellite networking. We need to understand how to solve them. And it's not really a new problem, right? We've done quite some work in Monet on wireless systems. So there's a lot of experience here. By better understanding the problem space and what needs to be done, eventually we could propose solutions that at least partially have been validated by IETF, and they're working code that could be at least theoretically applied to the problem space. And as of now, nor Starlink, neither other satellite providers are actually coming to IETF and asking us for routing. Every system is fully vertically integrated and runs proprietary stuff. But eventually, it will come to that. It's just a question of time, not whether. Okay, thank you.
Were you going to ask something, Garrett?
Yeah, I was trying to get my phone to load to get in the queue real quick. I suspect Tony's question is actually more of, is the intention of the satellite thing supposed to eventually get to a standards track where there would be multiple implementations? And I think that's where his original question came from. Is like, how do you test interoperability? It's not like I'm going to go and, as Akamai, going to launch a satellite, for example, and then implement my own routing protocol.
So I think it would look similarly to IGPs when we started many years ago. Every vendor would run their own stuff, right? Eventually, industry would push them to provide something that interworks, because no one wants to be locked into a single vendor, or in this case, single vertical provider. So I think looking at the past, that in the future, industry would require interworking solution, and testing is an interesting question, but had been solved before with routing systems, so I don't see any reasons why it wouldn't be solved with satellite systems. Tony, does it answer? Yeah, I'm speculating, right? I'm kind of trying to look into crystal ball.
Not really.
Just as a reminder.
I'm sorry, go ahead.
I was just going to say, just as a reminder to people at the mic, please identify yourselves. Thank you.
Sorry, Tony Lee, Juniper. So I still don't understand why we're taking this on if the relevant companies haven't decided to pitch in and propose something. They're doing it and we're not.
Yeah, so to repeat Alvaro's comment, we are not taking on yet. There are a number of people who is interested on working on it, and they brought their drafts to IETF and we have presented them. There's no formal, I'm not sure whether people who came up with this actually have satellite networking, but they're interested in working in this space, and it is related to routing. And in this case, we in routing working group decided to give them space to present their ideas.
So any further discussion of this topic should be in the RTWG mailing list. We had already the meeting on Monday afternoon, so we need to continue with the agenda. Thank you.
Thank you.
So you have seen only about a third of the working groups here, and there's a lot of exciting work. There's a lot of current work that needs participation and review and the input from all of you. So please, the objective of these short presentations is for you to see what is going on in other places. Now we have a something different. This is not something that's being worked in the IETF right now. But since the routing area open meeting is an open meeting and it's not a working group, we invited Adrian Perig from ETH and Apaya Systems to talk about Scion, which is something they've been working on for a while. They have deployments, and so he's going to provide an overview of that. Go ahead.
Yeah, many thanks, Alvaro. It's a great honor to speak here. It's quite amazing to see all the cool research and work going on in this group. So many thanks for the invitation. I'm very happy to give a high-level overview and dive a little bit into the details and talk about deployment of Scion. Can I forward or? Okay. So originally, in 2009, we looked at the research question of how secure can a global internet be? And so we, without any ambition to deploy, we started with this research question and tried to think from a clean slate, how could one design a highly secure interdomain routing system? And again, we had no ambition initially, and over time, the ambition has grew, and now we have 6 ISPs that offer SIGN connectivity to customers and with already productive use cases. And so on this journey, I'll tell you a little bit about what has happened. And we started with a security-centric design, so we tried to secure all the aspects of a communication architecture, also including secure control messages and so on and so forth. Really every aspect we looked at from an adversarial perspective. We also very early started with formal verification, and I'll come back to this in a minute. And also looked at scalability. How can we design a system that can have very rapid convergence to enable global communication? Next slide. So we're certainly not the first team who worked on this, and there are roughly several dozens of different projects, and we of course drew inspiration from many of these projects. Next slide. And so architectural principles we followed were to achieve stateless packet forwarding, so to avoid inconsistent forwarding state on different routers. So also the routing system itself has in a way no convergence phase, so it's always converged, so to speak, and that provides a lot of advantages. It's an instance of path-over networking, so the Panergy working group in IRTF is looking at path-over networks, and SIGN is an instance of such a protocol. It enables native multipath communication, and again, it was a security-based architecture with formal verification from the beginning. And I'll talk a bit about transparency and also sovereignty of networking in a minute. Next slide. So the first insight that we had on this journey is, and maybe it's obvious, but still I think it's useful to say this. If you really need high assurance for a large-scale distributed system, you really have to have a formal verification. And so we've done this in Scion and worked with research groups of David Bazin and Peter Müller at ETH, and we found a lot of bugs in the process, and were able to very early change the design thanks to such a formal verification. Next slide. So the first aspect of Scion that I'd like to present is that we started with us to achieve sovereignty of networks. So we said if the roots of trust, the cryptographic keys that define the trust roots, they need to be local. It's very difficult to create networks that have few of these roots of trust that are distributed in some way. And so we created a structure with isolation domains that would locally define the roots of trust and then globally connect and cross-certify each other in a way. So that was the initial idea, but then actually turns out this also helped with scalability, because the routing system then finds path segments across these isolation domains and also within each isolation domain. So that's the high-level motivation here. And next slide. And so here's an overview in one slide. I'll go a little bit into more details in the following slides. But in essence, in the control plane, path segments are being found through a process called beaconing. between the what we call core ASs, these are the main ISPs that manage these isolation domains. They have a process that looks similar to how BGP operates to find these path segments. And then within each isolation domain, the beacons are only sent by these core ASs. So leaf ASs, they don't themselves initiate beacons, and all the other ASs except the core ASs simply forward these beacons. So it's also highly scalable mechanism. And so these path segments are found in this beaconing process. They are then redistributed through a path server infrastructure that is pull-based and not push-based. So it's very lightweight and highly scalable way to disseminate these path segments. So you can think similar to how DNS works. And so when two entities want to communicate, so in this example here, we have a host in ASF who wants to communicate with a host in ASS. And so it looks up these path segments. In this example, it gets these 6 path segments that can be combined in only 2 ways in this example. Then it encapsulates this forwarding information at the AS level in the packet header. And so it can select for every packet which path it wants to take. The path information is also based not just AS level, but based on the interfaces between, or the connections or the links between the ASs. So you have diversity if the same set of ASs connects in many different places. So you can make use of all these different path options. So in the data plane, then we have these packets with this information. There's also cryptographic protections built in that prevent changes. And then in the end, routers become very simple. They forward the packets based on this information. And so in a way, there's no per path state on routers. Routers essentially have a cryptographic, actually only one single cryptographic key to verify this information, and it's symmetric, so it's extremely fast. It can be checked within nanoseconds. Right. Next slide. So in the control plane, we've seen how these path segments are being created. Then in the data plane, information is being extracted from this control plane information. And there's also cryptographic protections built in. So the control plane, we use digital signatures to authenticate this routing information or this path information. But then in the data plane, there is highly efficient asymmetric key cryptography used to then ensure that paths cannot be forged or changed in any way that is not permitted by the architecture. And so here we just see how fields are being extracted from the control plane and put into the data plane. So the overhead is 12 bytes per AS that's being traversed. 12 bytes is not little, but it's, we believe, given all the advantages, that's a good trade-off. Right? So for the actual forwarding, 2 AS operations are needed, and even in software on commodity Intel or ARM or other chips, AMD, it takes only about 30 cycles, processor cycles, to compute an AS operation. So this, on a, say, 3 gigahertz system, only takes 10 nanoseconds per operation. So this is, even in software, can be very high speed, and of course in hardware, it only takes a few nanoseconds to compute AS. So next slide. So just a few details to give you a bit more intuition how this works. So these beaconing process, we have these core ASs, so the main ISPs that govern an isolation domain. They initiate these beacons, then other ASs simply forward them across their interfaces based on the also routing policy. And actually, the policies, we try to be very close to the economic principles of today's internet, also with peering links and so on, where so Scion actually closely mirrors what happens in today's internet. So we definitely want to adhere to those principles. And so these path construction beacons, they create path segments that can then be immediately used for communication. Next slide. Next slide. Yeah, great. So then there's a path server also in each autonomous system that stores this path information. So an AS can select which paths it makes available. It can locally tell its hosts which paths they can use to, we call, go upstream towards the core. Or, and in the next slide, also there's a path server in the core where an AS can register how others can reach it. So that's on the next slide, please. And so here one can do, in a way, ingress path control by selecting which paths are being communicated to other entities for reaching its AS. And so one can register only the paths that are compliant with one's policy. And so then these paths, anyone on the internet can then fetch to communicate, in this example, with this ASS here. Okay, next slide. And so for communication, then these path segments are being combined in various ways. You can do also shortcuts, so you don't have to go all the way back to the core. But so here we see on this slide in blue, the what we call up paths from R to the core ASs. In green, the down paths to S that S has registered. And in orange, the core paths that also are needed to connect some of the up segments to some of the down segments. And then these yellow paths are the different paths that can be selected from. And we see also one example of a peering link where one can go and use the peering link from O to P, even though there's no direct link, so to speak. That is, where no beacon went across, but because both O and P announce the peering link with the right cryptographic information, one can then combine this and make use of the peering link if they have all the correct information. And so the peering semantics are very similar to today's internet. On the next slide. So here also on the global scale, these paths are combined. And again, we see several opportunities now. Maybe in this slide it's not that interesting, but in general, when we model the internet graph, of course, there's huge amount of path disjointness across the top ISPs. And so we anticipate that a really very large number of paths, assuming ISPs policies do permit communication, and a lot of different path choices become feasible. Next slide. So of course, there's also many drawbacks to SION. So initially, after DNS lookup, one also receives the isolation domain and the autonomous system number of the destination. And then the path lookup actually is only done with the isolation domain number and autonomous system number. And so the paths are obtained that way. And that, of course, requires additional latency initially to start the communication. Although that is amortized because several path choices then enable latency optimization or bandwidth optimization, or also the MTU is being provided also in these path segments. So there's no MTU discovery that is needed anymore. And so we believe that this initial increased latency is later regained and amortized to enable actually even more high-speed communication than if only a single path were available. Of course, there's also bandwidth overhead, and for this additional information, although we believe that these 12 bytes per AS is manageable, operationally there is more effort in a sense that it's a security architecture, so each AS needs to have a certificate that requires additional management overhead, and also the initial setup cost, training people and so on, is actually the biggest cost in SION, because people need to learn how this works. And for ISPs, though, it's turns out it's only a few days of training for their employees, but still, of course, that's a lot of effort. And that's actually more cost than the cost of the hardware that we've experienced. Next slide. So for an ISP, the deployment is actually quite simple. People have referred to as a homeopathic upgrade to an ISP, so it's not that much effort. In essence, the ISP set up a few border routers and path servers, certificate servers, and beacon servers, which are just hosts within the network. And so there's been a lot of surprise how little work it actually is to become a SIAN ISP. Of course, integrating this with internal processes can be quite complicated. But to get started, it's actually less effort than one thinks. Okay. And there's no changes to internal infrastructure of the ISP. That's also important to say. So SIAN can reuse the internal switching fabric, be it MPLS or an IP switched backbone or whatever. And SIAN traffic can reuse the internal fabric. Thank you. Next slide. Also for end customers, the deployment has been actually quite straightforward because of a SIAN IP gateway that translates between IP and SIAN traffic, so the end applications, end hosts don't need to even know about this new infrastructure. And so several customers use this in production actually already for several years and benefit from the opportunities of SIAN without having to change any of the applications. Of course, there's also end host stacks that can then make use of SIAN natively. But initially, it's of course much simpler to transparently translate between IP and SIAN. Next slide. So the current deployments are led by Anapaya Systems. The global SIAN network was constructed in a way that it's not an overlay, but it's really has independent failure models from BGP. So there's no dependence of the today's SIAN backbone on BGP. So that's already quite nice to have these two independent systems, even though they run over some of the same networks internally. There's also 3 different implementations. There's an open source implementation in Go. Anapaya has their own proprietary high performance implementation, and Sind Labs built a SIAN router in P4 that achieved over 1 terabit of throughput. And these are the current implementations. The deployment, there's 6 ISPs that offer native SIAN connectivity, the first 3 in Switzerland, and the others, actually Cyberlink is also in Switzerland. But of course, additional ones exist and are already trying out, so one can get SIAN connectivity, for instance, in any household in South Korea. And it's also spreading in the sense that more and more ISPs are interested and are joining this network. Also, IXPs are making use of it. And I should also say the whole deployment has been driven by Swiss banks who are interested in secure communication. And so they built a secure Swiss finance network that makes use of this technology. And the early parts are going back production uses to 2017. So the technology has been in production now for almost 5 years successfully. Next slide. So for standardization, there's of course work to be done, and that's why we're here. And I believe we satisfy a lot of the success factors needed for standardization in RFC 5218. And we've also had a site meeting yesterday to discuss how we could go about this standardization. And we're very much looking forward to also feedback from this group to getting your advice how we could proceed. Next slide. Lots of resources exist, code and on SIAN architecture, papers, a book. There's also a new book coming out. We're just waiting for the printer to hit the print button. So hopefully the new book from Springer Verlag will be coming out within a few weeks. Next slide. So one observation I briefly wanted to talk about was that stable paths and multipath is necessary and not just a luxury. So with single path forwarding, it's difficult to achieve strong availability guarantees. For instance, during route convergence, and we've also seen one has to do work to prevent routing loops. So during protocol convergence, no path may be available, and it can take some time for routing protocols to update. And so the point here is that having a native multipath protocol enables very quick failover in case of link disruptions or path disruptions by allowing the application to switch to an alternative path that's already operational. So I'll give in the next slide next two slides two examples for why this is necessary. So the first one is about bottleneck routing. So we've seen several real-world events that were quite noticeable at the global scale of outages, where the protocol changed to a path that had insufficient bandwidth, and then resulted in high packet loss. So the path was operational, but had such high packet loss that applications were not usable. And it took quite some time to recover, because the routing system thought, well, the path is working, but in fact, for applications, it was not practically usable. And so this is one example where even a secure protocol would not have operated, because in both of these cases, the path that was switched to that had insufficient bandwidth was a correct path. So security by itself would not have addressed this issue. And then the next slide, we see another example of where withdrawals messages were not being sent. And so there was an outage because of the lack of the withdrawal message. So then on the next slide, we see that the insight I'd like to share here is that a secure routing protocol is actually not sufficient. One really needs a multipath system to be able to deal with these cases, because in some cases you have correct messages that then result in outages. But having a native multipath system with several choices then allow you to very quickly switch over to different paths. Next slide. So in summary, SAN connectivity is available today. It's already in over 180 data centers across the globe where you can get native SAN connectivity at. And so that's quite exciting to have an independent system that is there, that is already available today. It's also high performance, because path-aware networks allow you to perform application-specific optimizations, and that is not just for security, but also has the opportunity to give higher performance to end applications. And also, of course, the whole system was designed for high security, high assurance, high availability, to also even with secure control messages and so on. So really security up to the last point. And this has been a 12-year-long journey for us, starting actually in 2009. And the team is at ETH, and several collaborators is shown on the next slide. And so many thanks for your attention. I'm not sure if you have time for questions or.
Yeah, thank you, Adrian. We have some time for questions or comments. Please get in the queue if you have any question or comment for Adrian about this. Get in the queue, meaning in the Meet Echo, but go ahead. Tortoise
I'm just trying, I'm old timer pre-COVID.
Let me remind you. If you know who you are.
I just said, so yeah, audio sucks. I didn't see from well, thank you very much for the presentation. That was very nice. Although kind of I knew it, but anyhow. I didn't quite see, some background information about, who would be the operators of the current, deployment that you have in terms of, you mentioned 180 data centers. Could you kind of elaborate a little bit about that current operational, motivations or so, who those folks are that are running the virtual machines, I guess, or and what their experience is?
Right. Mm-hmm. Yeah, very good. Thank you. So in Switzerland, we have Swisscom, Sunrise, Switch, and us as the main operators, and now Cyberlink as a new ISP joining them. And globally, InterCloud has this network where they're offering cloud connectivity. They're at over 180 data centers where they then provide also connectivity inside cloud deployments. And so their offering is to provide native SIAN connectivity also inside cloud deployments. Also, Telindus in Luxembourg is one of the ISPs, but there are more coming. Some of them not with official products, but doing more POC-like offerings. But the network is growing, and there are more and more ISPs now joining this network. We're simply looking out to make sure that it is running independently from other systems. So if other systems fail, SIAN would not be affected, and of course vice versa as well.
No, because I mean, you've been asking about, you know, how to proceed with something like this in the IETF, and typically the best driver to do something is to basically show the need to define the interoperable components of something like this. If it's in routing, then the routing components, of course, you may be driven around different areas depending on, you know, oh, the security aspects, we have no idea, we tried and failed, go to security area and so on. But effectively, it is exactly what I was asking for in terms of a list of operators that want to have this, that feel that if the IETF provides standardized RFCs, that it helps them to achieve for what they've already been doing in their private Idaho, so to speak, so far, a better, reliable, standardized, interoperable experience, right? So I think that's going to, and Alvaro can probably tell you a lot more about that. I think that's the starting point to figure out the strategy on how to proceed with this in the IETF.
Hi, I'm Simon Leinen, responding to Turles's question directly. So I'm with Switch. We're one of those operators who have been running SIAN services, and we're offering this on a commercial basis for a deployment in the financial industry mostly. Well, our interest is that this becomes something sustainable and independent of from like a research group or startup. So of course we will be happy for this to be standardized in a sort of a neutral forum. That's one aspect. Also, probably the quality of the implementation would also benefit from review in a forum such as the IETF. Yeah, as to how to bring this work from the academic research sector, but also from operators who are not necessarily used to interacting with the IETF, is a different question, and I guess that's sort of for the IETF bureaucracy to facilitate. Yeah. But if you have questions about how this feels to an operator, I'm happy to talk to people. Thanks.
Thank you, Simon. Jeff?
Jeff Tensura. So first of all, I'm happy to see you here. We've been discussing a couple of years over LinkedIn messaging, right? It was a good idea to come here. So next step would be to really decouple problem spaces. It's not just routing, it's name resolution, it's addressing. There are more things that are not standardized by ETFs today, right? So when someone seeing this for the first time, it looks like boil in the ocean because you're replacing DNS. You're talking about stuff that's really incomprehensible to some degree. So you came here to meet us as well, right? It goes both ways. So you figured out already that there's area that works on DNS, area that works on IP addressing, area that works on routing. This is where you are now. Try to break your problem statement into smaller, comprehensible pieces that could be addressed by particular areas and people who know what this is about. That would be really good next step for you.
Yeah, thanks. Thank you very much for the advice.
Jared Mach. So I think similar to the side meeting that we had yesterday, it would help also to understand, is the intention to bring the SIAN work forward or is it to go and bring the technological capabilities that was developed as part of Scion into the other protocols that are already existing within the IETF, and determining sort of which pathway you're looking to go. That would, I think, help a lot of us, because similar to what Jeff said, it does feel a lot like boiling the ocean. And so if we're trying to say, okay, we need to go and secure these protocols, we need to secure them, as I brought up yesterday, start down at the link state where we traditionally build a lot of the networks, from there on up, and figure out, okay, what infrastructure needs to be changed or modified or improved in order to have the properties that make this valuable for the financial institutions and others that are using it, and to have a much clearer, kind of a clearer goal set out of there. So if you have like comments on that, if that's the intent, or like if you're trying to improve the protocols such that they have these properties, or if the goal is to bring this forward independently and have this be another overlay network that people can run on top of IP.
Right. So the intent is definitely to bring the whole protocol to standardize, and with all the consequences, but of course also having cross-fertilization with other efforts to see how can they benefit from Scion and how can Scion benefit from them. I think there's also a lot of possible interactions with segment routing, for instance, and other working groups as well. So I think there was one more point, but it just escaped me. But that definitely, I see there's a lot of potential possible interactions with different groups and different efforts, and including improving Scion itself and making it better over time.
Hello, Antoine Franco, Huawei. In fact, this example of a World Protocol suite addressing a set of use cases that are very interesting to customers for specific ISPs relates to, for me, to the question of deployments of experiments or lower market use cases in networks that are used in production. And it relates to a work that has been presented in IETF, I think 1 or 2 meetings ago, about TCP/LS, and the members of the TCP/LS team have proposed a mechanism called protocol plugins in order to deploy innovation in actual production networks in the form of small VMs. So maybe one work that could be interesting to do in IETF would be to have a method for researchers and people willing to deploy new use cases and new protocols to interact with vendors and operators to deploy those new things and find ways to manage their experiments in isolation for the time they are not successful enough for wide adoption, but yet not harming the running of the operational networks. And I think it would be a very valuable work to do in IETF to address the problem of the ossification of the internet.
Thanks, Antoine. Jeff?
And the timing is impeccable. At least in US part of the world, FCC has published request for information just 2 weeks ago asking how come BGP is so insecure, right? With war in Ukraine and everything else, the visibility of insecurity of routing system got bumped up to the highest level. So I think we are going to see more funding and more industry interest, because finally there is a driver to go to the next step, right? I think they are very surprised that BGP-SEC is not only not deployed, there are no commercial implementations, at least not shipping implementations. So there's going to be a huge push to do something on top of origin validation. And it's going to be either BGP-SEC, something better, something probably more deployable than this, but a solution needs to come. I mean, finally, there is interest of government, there's money, there's industry pushing for it. So
great, good time. Thank you. Great.
Great. Thank you, Adrian, so much for being here. So we have about 15 minutes left for anything anyone else wants to bring up. Questions, comments, concerns, flames, chocolate. Chocolate? There we go. Anyone in the room or remote, you can get in the queue. Well, I guess unless John, Andrew, Martin, you have anything you want to say, I think we are done for today. Hopefully we'll see each other again and more of us in person and not wearing our masks so often. Thank you everyone for being here, both here and online. And again, we'll see you next time. Bye-bye.
Thanks, everyone. Bye.